Hello friends, I hope you have understood the previous question that we have solved in the last video, and I hope that you have solved it on your own, calculated each and everything and got the correct answers. Still, if you have any query, you can comment at any point of time in the comment box, so that I'll revert back to you and give the answers to each and every question. So now, without wasting much more time, I'll proceed for the second question, and here they have given that a string ABCD. So you can see here ABCD string attached to a fixed points A and D. So these are the fixed supports. You can see where the cable segment AB and CD are connected respectively. Has two equal weights of 1000 Newton attached to it at B and C. So here 1000 Newton and so here 1000 Newton and 1000 Newton. So two same magnitude weights are attached to that cable segments at point B and C. The weights rest with the portions AB and CD inclined at an angle as shown in figure. So you can see here the different angles are given 30 degree and 60 degree with the fixed supports, and angles are with the vertical axis 30 degree and 60 degree. Then find the tensions in the portions AB, BC and CD. So we have to find the tensions in the AB, BC and CD, these three segments. I have already explained you in the last video that cables or strings always carry a tensile force. Now they mention that we have to calculate the tension in each segment of the string if the inclination of the portion BC, of the portion BC with the vertical is 120. So they have given here angle with the vertical, that is 120 degree. So now our first step in order to solve the problem of equilibrium of coplanar concurrent force system is to draw FBD, free body diagram. So in order to understand FBD, let me first enlarge this figure. Okay, so now you can easily understand the different angles and free body diagram of each and every point. I'll go one by one to all the points. Now I'll start with the point A. So at point A, only one segment, that AB, is connected. So only one tensile force, and A point is under consideration. So tensile force is away from the A. So I'll show it over here. Now if I consider, see, this is tension AB. Now if I consider point B, so two segments are connected at point B and one force, that is 1000 Newton, acting vertically downwards. Okay, so here I'll go ahead with the, so this is 1000 Newton vertically downward, the first force. Then I'll consider this TBC away from the point B, and then this third force. So this is TAB, this is TBC, and this is 1000 Newton. So at point B, you can see there are three forces passing through it, and they form a concurrent force system. And out of that, one force is known to you, that is 1000 Newton, and all other angles you can easily calculate. So B point can be considered for the further calculation. Now I'll proceed for the point number C. So at point C, again 1000 Newton, the force is acting vertically downward. Then this cable segment CD is connected at point C. So tensile force away from point C. This is TCD. And of course, this is TBC, getting away from point number C. So again at point C, all conditions required to apply Lamis theorem are satisfied. So you can consider point C for the further calculation. Now the last point is left, and that is point D. So you can see only one cable segment is connected at point D, and it carries only one tensile force, that is TCD. Okay, so here it is mentioned already. So after analyzing the whole FBD, that we have discussed here, we can proceed with the point B and point C for the further calculation. So now I'll consider FBD for the B over here and then for the C, and then we'll do a further calculations. I hope the idea about the FBD is getting clear to you. Still, if you have any query, you can ask at any point of time in the comment box. Okay, now for the further calculations, we are considering B and C. Okay. First, I'll draw required axis, vertical and horizontal, for both the points B and C. Now I'll consider one by one all the forces. Okay, so at point B you can see 1000 vertically downward. So this point is B, it is vertically downward. Then tension AB, okay, and then tension BC, then the tension BC. I'll give the names to each and every force. This is TAB, this is TBC, and this is 1000 Newton. Okay. Now the thing is that angles for the applying Lamis theorem. So if you go through this, you can easily understand. Sorry. Okay, coming to first point number B. So if I consider an axis over here, okay, so this is nothing but 30 and this is 90 degrees, so this becomes 60 degrees. Okay, this becomes 60 degree. So TAB is making angle 60 degree with the horizontal, or you can say alternate angle. This is 30, so this also becomes 30. So 30 degree with the vertical or 60 degree with the horizontal, one and the same thing. And if I come over here, if I draw a horizontal line through point C, then you can see here, this is 60 degrees, so of course this is 30 degree, because if I consider this and this, so this becomes 90 degree. So 60, 30 and 90. So TCD is making 30 degree with the horizontal. Now same thing we can consider over here, this angle, okay, this angle. So now with the horizontal, if I draw a line over here, this total angle is 120 and this is 90. So this is 30 degree. So of course alternate angle, this becomes also 30 degree. So TBC is 30 degree with the horizontal. Okay. So coming back to the FBDs. Now we have all the angles, so we'll come back to the FBD to solve the problem. Okay. So TBC is 30 degree with the horizontal, or okay, fine, we'll discuss this later on while completing the total angle. Okay. Then this is 60 degree with the horizontal. Now I'll come back to the point number C. And I'll draw all the forces acting at point C. So at point C, you can see three forces: 1000 vertically downward. Okay, this one. Then TCD at 30 degree with the horizontal. And finally TBC at 30 degree with the horizontal. Sorry. I'll give the name to each and everything. So this is TBC, this is TCD, and this force is 1000 Newton. Okay. Now here angles are 30 with the horizontal. This is 30 degree as per the question. So this point is B and this point is C. But to apply the Lamis theorem, we know that we need a total angle between the forces. So in the next step, now we are calculating the total angles like we did in the previous question. So I'll start with the B. Okay. So one can see here, this is a 90 degree. So 90 and 60 becomes 150. So this total angle is 150. Now if I consider this one, so 90 minus 30, so this becomes 60 degrees. So angle between these two forces is 60 degree. So 150 plus 60 becomes 210. So remaining angle is 150. Okay, 150. So this angle is 150. See, 150 plus 60, 210. So the remaining angle between these two forces is 150. Or you can go like this. In the question, they have already mentioned this is 120. 120 plus 30, 150. Now coming to this question, this point C. So this angle is very easy to calculate. Thirty, 30, 60, 180 minus 60. So this becomes 120. Okay. Now this is 90 that we know. So 90 plus 30 again 120. And this is again 120. Okay, now we'll apply Lamis theorem first at point number B. So according to Lamis theorem, if I consider 1000 Newton, then it is proportional to the angle, sine of angle between other two forces. So let it be start with the known force. Okay, so it becomes very easy to solve the problem. So 1000 divided by sine of angle between other two forces. So 1000 is the force, remaining these two forces, so sine of 150. Which is equal to, now I'll go with the TAB. So TAB upon angle between other two forces, that is 60. So sine of 60, which is equal to TBC divided by sine of angle between other two forces, that is sine 150. Okay, so this is the equation considering point B. Now you can equate this fractions to get the TAB answer and then the answer of the TBC. So let's go ahead. So TAB, the equation will be 1000 upon sine 150 into sine 60. And for the TBC, again 1000 upon sine 150 into sine of 150. You can see here, first I equated these two ratios. So TAB is equal to this sine 60 will go here for the cross multiplication. So 1000 upon sine 150 into sine 60. Then I equate these two equations. So 1000 upon sine 150 into sine 150. Okay, so here you can see by observation only, you can say this 2 gets cancelled, sine 150, sine 150. So TBC becomes 1000 Newton. Okay, now TAB. So we can calculate here. So 1000 into sine 60 divided by sine 150. So this coming out to be 1732.050. Okay, so I'll write here the calculated answer, 1732.05, and I'll take it as a 1 Newton. Okay, so here I'm getting TAB is equal to 1732.051 Newton, and TBC is equal to 1000 Newton. So these are my answers considering point B and after applying Lamis theorem. Now I'll use this values to solve the remaining unknown considering point C. So now at point C, now I know the value of TBC. Okay, I know the value of TBC. So the value of TBC is, we are getting TBC here, 1000 Newton. TBC is equal to 1000 Newton. Okay, so I'll mention it over here. This is equal to, so this is equal to 1000 Newton. Now I'll apply Lamis theorem with the known value, of course, first. So 1000, and you can see here the all angles are 120. So here the thing is like 1000 upon sine 120 is equal to again TBC, that is 1000 upon angle between, sine of angle between other two forces, that is again sine 120, and which is equal to TCD upon sine of angle between other two forces, that is sine 120. So this is the equation I'm getting after applying the Lamis theorem. So if you equate any of this, you will get TCD by observation only. You can say TCD is equal to 1000 Newton. So this is the answer for the TCD. Okay, so here we have calculated each and everything, and we got the answers for all the unknowns, or you can say the tensile forces which are present in the given cable system. Okay, so I'll quickly revise what we have done in this solution. So we started with the understanding the question. So there are three segments, AB, BC and CD. We have shown how the forces are acting at each and every point in the given question, and then we completed the FBDs according to the same. So after analyzing the forces acting at each and every point, we finalize point B and point C for the further calculation. Then we calculated all the angles required for the applying Lamis theorem at point B and C. So after that we got these two equations, and solving these equations we got the final values of TAB, TBC and TCD. So guys, please do practice, solve on your own, use calculator and get the familiar with all the functions of the calculator, and that will enhance your speed in the examination. So you can solve the problems quickly, understand the problems quickly. I hope this question is clear to you. Still, if you have any query, you can ask me in the comment box. And if you have any other questions that you want to solve by me, you can just mention it in the comment box and I'll definitely solve it for you people. So in the next session, we will solve the problems based on the Lamis theorem only. So let's start with the next question.